A sports club owns a field PQRS. A scale diagram is shown in which 1 centimeter represents 10 meters. The field is to be divided with a fence from P to the side RS. Each point on the fence is the same distance from PQ as from PS. That's a mouthful, but we will dissect this problem. The field is to be divided with a fence from P to the side RS. The fence will go from P and it will meet the side RS. But where? That's the point P, and the fence will be represented by this straight line, and it needs to meet RS. So the fence will intersect this line at some point that we do not know as yet. What we know is that it will go from P to some point on this side RS. The fence must go from P to a point on RS, but where? Now, the fence will go somewhere along that line. Each point on the fence is the same distance from PQ as from PS. Each point on the fence must be the same distance from PQ as it is from PS. Each point on the fence is the same distance from PQ as from PS. That means that any point on the fence, it will be the same distance from this line segment PQ as it is from this line segment PS. For each point on the fence to be equal distance from PQ and PS, the fence must bisect the angle. That means it will divide the angle into two equal parts or two equal angles. That is the angle that we need to bisect. When we bisect that angle, the bisecting line will be equal distance from PQ and PS. The problem therefore merely requires that we bisect the angle QPS. It merely requires that we bisect this angle. Before we do that, get familiar with your virtual compass and pencil. The red dot represents the point of the compass and the blue triangle represents the point of the pencil. There we have the pair of compass with the pencil fitted to it. The red dot is the point of the compass. The blue triangle is the point of the pencil. Let's go. Bisect the angle QPS. That's what we need to do. Place the compass point at P. There's your compass point at P. Without adjusting the compass, make two arcs to cross PQ and PS as shown. We are about to bisect the angle. We place the compass at P, which is the vertex of the angle, and we will make two arcs without adjusting the compass. Those are your two arcs. Now, why is it that we should not adjust the pencil while making, or the compass, while making those arcs, because we need the distance from P to this arc to be the same as the distance from P to this arc. We therefore need to make those two arcs without adjusting the compass. Place the compass point at the point of intersection of the arc and PQ and make an arc. PQ, point of intersection with the arc and PQ, right there, and we will make an arc. The compass point, red dot is there, the pencil is used to make an arc, like that. And of course, we imagine that we need to do the other, which is of course analogous to this one, or we may call it the counterpart. Place the compass point to the point of intersection of the arc and the line PS, and we will make another arc. So these were the first two arcs. We move the compass point here. It just makes sense that here is where we will place the compass point next. And we will make another arc to cross the first one. All of that is done while not adjusting the compass, because we are designing symmetry. The distance from here to here must be the same as the distance from here to here. Also, the distance from here to here must be the distance from here to here. The fence will go from P through the point of intersection of the two arcs until it makes contact with RS, like that. It will go from P through the point of intersection of these two arcs till it gets in contact with the line segment RS. Notice that it is not bisecting RS in any way, which is not expected. It is only expected that it bisects this angle that we have right here. The diagram is not drawn to scale, but the principles of construction are correct. This is a computer-aided design and not necessarily drawn to scale. However, the principles used in the construction are correct. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.